The following problem can be found in this book on the notation to the right.
Hello, I'm Anthony, and today we'll be talking about this problem. So the problem states that a stunt driver wants to make his car jump over 8 cars parked side by side below a horizontal ramp. We're going to answer part A today, which is, with what minimum speed must he drive off the horizontal ramp? The vertical height of the ramp is 1.5 meters above the cars, and the horizontal distance he must clear is 20 meters. So basically, we have to get the car, what minimum speed it takes to get the car from here to this point without hitting any of the cars. Okay. So, first things first, we're going to plug in what we know. And we already have a table here ready for us. So let's just fill in all the numbers. Let's just put in all the numbers. Okay, so initial x is 0, initial y is 0, because we set origin at the car. The x is, well, that's 20 meters. And the y is 1.5 meters down, so negative. Initial velocity of x is, well, that's what we're trying to find here. So those are both unknown. The initial acceleration of x is 0, because this is constant acceleration. The initial velocity of y is, there's no initial velocity because it's going straight off the ramp. And the acceleration of y is, it's always negative 9.8 meters per second squared. And time is, we don't have that. So first things first is that I'm going to find time. I'm going to use that using equation number 2 for the y direction, since we know all the values in y. So let's get started. Let's draw the thing out first. Y equals y initial plus initial velocity in the y direction times time plus 1/2 acceleration in the y direction times time squared. Okay, so the final position of y is going to be 1.5 meters. I'm just not going to write out the meters part to save space. Equals 0, because the initial place of y is 0, plus the initial velocity of y is 0, so that just dies off, minus half of 9.8 is 4.9, and t squared. So if we rearrange that, we get t squared equals negative 1.5 meter over negative 9.80, and that comes out to 0.55 seconds. Now we find the initial velocity. Now that the only unknown variable left is initial velocity. So let us use equation number 2 again, but this time in the x. So I'm just going to write it out. Final position of x is 20 meters. Initial position of x is 0 plus initial velocity in the x direction, which we don't know, times time, which is 0.55 seconds, plus there's no acceleration there's no acceleration in the x direction, so I'm just going to cross that out. So we have the initial velocity in the x direction is 20 meters over 0.55 seconds, which is rounds up to 36 meters per second. And that is the initial velocity at which we need the car to go to clear all of these other cars. Thank you for watching, and we'll be doing part B in the next video.